There's y'all a fun little warm up to try. All right, guys, so it is 1:15, so I'm going to go ahead and get started. Yesterday we started our notes dealing with these limits graphically. If you want to write this down, you can, or you can just kind of think about the answers in your head and we'll go over it in about 45 seconds. But I have just a small graph here and then 5 questions for limits and then 1 dealing with a value just to kind of test your knowledge of what we've done so far. And then my plans for today is that I have, I'm going to talk about asymptotes and limits. And then we will also, I have like a little classwork activity to see how well we've processed limits. But go ahead and try these 5 for me, whether you write them down or just kind of think about them in your head. All right, so I'm just going to go ahead and walk through this. It's kind of hard to call on kids as I'm going over it, so I just will kind of walk through each piece. So this is the function f of x. We remember that when we see the little plus sign in the exponent, that means you're coming in from the right-hand side. When you see the minus, you're coming in from the left. If you don't see a plus or a minus, then it means you have to consider both sides. So looking at number 1, it tells us that we are looking at the limit as we are coming in from -3 from the right-hand side. So looking at -3 coming in from the right, we can see that it is a whole, but it doesn't matter. Coming in from the right, you should see that is approaching the y value of 3. Remember, the answer to a limit is always a y value. Number 2, this has a minus sign, so we're looking at the limit as x goes to -3 from the left. Coming in from the left-hand side of -3, we see that we are approaching the y value of -1. It wasn't asked, but I do want to review this concept. If I just asked you to find the limit as x goes to -3 of f of x, and there wasn't a plus or minus, you would need to consider both sides. Since the left-hand side and the right-hand side are not equal to each other, then we know that the limit as x goes to -3 of f of x does not exist at all. The next one, I have the limit as x goes to 4, no plus or minus, so we need to consider it from both sides. So here's 4, coming in from the left, I approach the whole, coming in from the right, I'm approaching a whole. Even though it's a whole and the point is above it, that doesn't matter. We will say the limit is approaching the y value of -3. Then I have the limit as x is approaching 0, coming in from the left and the right. That's an easy one. The function is clearly there. That's going to be the y value of 3. And then f of 4 is a value. So f of 4 is where the point is actually located at. The point is actually located up here at 4. So we know that f of 4 is equal to 1. I can actually combine a statement about the limit and the value at 4. And this is an example where the value is not equal to the limit at that same x value. Any questions or concerns or anything else you want me to explain about that graph?
Yeah, could you go over number 4 again?
Number 4, yes. So the limit as x goes to 0, x goes to 0 is, so there's the value x going to 0. So just looking at the left and the right-hand side of the graph. Coming in from the left, coming in from the right, what y value is it approaching? It's approaching the y value of 3. Any other questions?
So it doesn't matter if there's no hole there, as long as it's like approaching something from both sides, it still counts?
Correct. So one way I kind of think about limits is you don't care, like at that number, don't care like what it's doing at that spot. Just look immediately to the left and immediately to the right. Unless you're, of course, doing a one-sided limit. So yes, it doesn't matter if the point just actually exists there or if you have an open circle. You're only concerned about what it is approaching. Anything else? All right. So we're going to go ahead and continue the notes that we started yesterday. We were talking about a bunch of different types of limits that we can have. Today I wanted to focus on some of the ones dealing with some asymptotes. So we have two types of asymptotes that we'll be dealing with in AB. We have both horizontal asymptotes and vertical asymptotes. Technically there's also slant asymptotes, but they're really just not as interesting as horizontal and vertical when it comes to limits. So in red and green, I just kind of have two examples of what a graph could look like. And I want to talk about like what's the limit as x goes towards negative infinity and as x goes towards infinity. Remember, whenever you're looking at a limit that's going towards infinity, whether it's positive or negative, you're always talking about what's happening on the extreme sides of the graph. So let's do the red one first. The red one is an exponential function, is the one that I used to create it. So if we're looking at that graph and I see that x is approaching negative infinity, the question I want to ask yourself, would the limit as x goes to negative infinity exist or would it not exist? And would anyone have a guess as to the limit as x goes to negative infinity?
It doesn't exist because it's going towards negative infinity.
I might have just said it wrong. What about the one going, let's do the negative infinity one first. So remember when we're talking about as x goes to negative infinity, you think about the horizontal motion. Negative infinity is the far left and positive infinity is the far right. So of those two, let me go back and just rephrase the question better. For the red one, I have the limit as x goes to negative infinity, and then I have the limit as x goes to infinity. One of those exists, and one of them is D and E. Which one of them would exist?
Wouldn't negative infinity exist because it would be approaching the asymptote, so the value would be the asymptote because that's what it's
Very
approaching.
good. Yes, so this is the one that would exist. And it is existing because it's leveling off at a horizontal asymptote. I didn't put this on a graph, but like if this asymptote had been at say like y is equal to 3, then we would say that the limit is equal to 3. The other one is the one that is D and E. The reason why it does not exist is because the graph is always going down towards negative infinity. So since it does not level off, it's going to be D and E. And that's kind of a one important thing to notice when you're talking about limits at infinity. If it levels off, no matter which way it levels off. If it levels off, then the limit's going to exist. If it's not leveling off, then we're going to say that the limit does not exist. Questions about that red graph?
No.
Good. All right, so let's look at the green one. Again, with that green one of those has a limit that exists. One of the limits does not exist. Any ideas of which one is the limit that exists? The negative infinity one or the positive infinity one?
Positive infinity.
The positive infinity. So this is a graph that's kind of going up and down. It's not really a trig one since it does have a spot that's getting narrowing. It's actually called a dampening trig function. But it is oscillating, going up and down, up and down. The one going towards positive infinity is beginning to level off. Like it might still be going up and down forever, but it's getting closer and closer to a certain value. So the one going to infinity is going to exist, and it would be whatever that asymptote is. The one going towards negative infinity, like it's not getting smaller and smaller, so it's always going to be going up and going down. It's never settling on anything. So it's going to be the one that we're going to say does not exist. The reason we say it does not exist is because it is oscillating, which I apparently can't spell, but oscillating. Yes, Mitch?
So does the limit going towards the infinity, does that have a horizontal asymptote as well, or no?
It is so, and that is something I probably want to correct. When you were first taught asymptotes, you were probably told by a teacher, through no fault of their own, that like a function can never cross an asymptote. And that's kind of a lie. A function will never cross a vertical asymptote. That deals with the domain restriction. But a function can cross a horizontal asymptote because horizontal asymptotes really just talk about the end behavior of a function. So a horizontal asymptote couldn't care less about what's happening on the function except at the very, very extremes, at positive and negative infinity. So like in this green one, that dotted green line would be considered an asymptote, but it's really only affecting the positive side as you go towards positive infinity.
Yeah.
So, like, how do we know that it's not continuing to oscillate on the end?
We're making assumptions that it's not going to get any bigger.
Okay. Okay.
Yeah, we're just making assumptions based off of the graph that we see. Any other questions? All right, so let's pull all of this together. Some students I find like limits graphically just clicks with them. And so here are vertical asymptotes. I have 4 statements underneath each picture. So I have the orange one and the x value of c, and then I have like a purple blue one with the x value of c. And I'm asking about the limits from the left, the right, both sides, and the value. Whether you write this down in your notes or not is up to you, but I just want you to figure out if it exists or doesn't exist for me kind of real quickly. People tend to be a little bit better with vertical asymptotes over horizontal. So again, we don't have any numbers, but I just want you to determine if it exists or doesn't exist. And then we'll really pull it all together for the classwork activity. All right, so let's look at the orange one. Limit as x goes to c from the left. Exist or not exist?
Yes.
Exists.
Yeah. Yes.
If you're saying existing, what are you saying it's approaching?
The vertical asymptote.
It's a vertical asymptote. It's going up towards infinity. So you could say the limit is infinity, but remember, if a limit's going to infinity, it's perfectly fine to say does not exist. Because remember, infinity is not a number. So saying D and E would not be incorrect. What about the limit as x goes to c from the right? What would you say the limit for that is? Exist or not exist?
D and E.
D and E. So technically, I would again argue D and E is probably the better answer for that one. But again, infinity would not be wrong. What about the limit overall?
D and E.
Same thing. They're both going up, but D and E is probably the better answer, but you could say infinity. And then does the value exist for that function?
No.
No.
No. And when it's the value, so I tend to reserve does not exist for limits. For the value, undefined is the word we tend to use. Like if you put D and E, would I mark it wrong? No, but undefined is just a little bit better in that case. What about the purple one, bluish one? Limit from the left, would it exist?
No.
Nope.
Nope, it's the other one, so D and E is fine. You could also say positive infinity. Does the limit from the right exist?
Yes.
Yes.
Yes, it does exist, and it would be some sort of number, whatever that whole is. Since those aren't the same clearly, the limit is D and E from both sides, and since it's a whole and not a closed circle, the value is undefined. So between yesterday and today, we looked at a whole bunch of different examples dealing with limits graphically. So now I want us to have a chance to get it all together. Now I've had some halfway success with me sending out pages in OneNote, so we'll see how well 6 period stuff was sent out today. But I shared with you sometime yesterday a handout that I would like for you to try. If your OneNote is not syncing, that's fine, because I actually have just a copy of it on the next slide, and you can just kind of look at it and do it in your notes. I'm not grading it, but basically if you go through the pathway of opening up your OneNote, going to the Unit 1 section, and then the Notes tab, fingers crossed you have a page in there that says something like show what you know limits. And the problem looks something like this. So if it didn't sync, I apologize, and I will work on that once class ends, because apparently in 5th period it was like 50-50 of whether it went or not. You might need to right click and sync it. But basically if you go under Unit 1 Notes, it's something show what you know. What I've done, and I'm going to give you quite some time to kind of play around with it, I have given you 7 characteristics, and I want you to draw a function that would end up having those characteristics. This is kind of working backwards. I would take it piece by piece. I'm not grading it, but I am just going to kind of skim through OneNote before I see you again in class, and make notes if I see something that's like clearly wrong and that I want to fix. There is an infinite number of possibilities you could draw, but I mainly want us to focus on, can you make sense of, like, when I see a statement that says this, can I figure out what that looks like graphically? Last thing I'll say, and I'm just going to kind of be quiet and let you work and see how well you can do. This does need to be a function, so your final answer does need to pass the vertical line test. So like if you draw a vertical line, you cannot hit the graph more than once or it's not a function. So you might have to go back and erase some things. But go ahead and see if you can draw a graph that has these characteristics. For me, if I was a student, I might just make some notes beside each letter first, just kind of thinking about what it would represent. Like, is it describing a hole? Is it describing a jump? Is it describing some sort of asymptote? And see if you can make sense of what it means. I'm just going to kind of sit behind the screen And if you want to unmute your mic and ask questions, you can, but I'm going to give you about, we'll say about 8 minutes, so I still have time to go over it. Maybe 6 minutes if I start getting really bored sitting in here by myself. But go ahead and see if you can draw a graph that matches what is described. And this is the last thing we'll do today. And I really can unmute your mic and ask a question because I'll get bored.
Can you do the first one?
I'm not going to do it, but we can talk about it while you're thinking. If I see the limit as x goes to negative infinity, I know that anything towards infinity is describing an end behavior. So to me, when I read that, it tells me that as it goes towards negative infinity, the graph should somehow level off at -1. Whether it just is -1 or there's an asymptote there, it needs to level off at -1.
So is -1 a value?
It could be.
Okay.
It's a limit at infinity, so all we really know is that it is showing a trend for the end behavior. So basically on the far left-hand side of your graph, it should be leveling off at -1. Is how I would consider that. Some of the other ones, if y'all are drawing it, I would think of like, if the limit overall doesn't exist, I mean there's no plus or minus, then I probably have things like maybe a jump, or maybe there's an asymptote there. Careful with sometimes the hole, there is a hole, maybe there's a hole with a point above it, but see if you can kind of make sense of these different things. But I would definitely take it like x value by x value. And it will be some crazy looking function when you're done. All right, so I'm going to go ahead and start talking about this. Please interrupt me as much as you need to. And I'm just going to do like a few at a time, put it on the graph, go back and do a few more and put it on the graph, and then kind of see what it looks like together. So the first thing I know is that when I see something as x going to infinity, to me that often is describing the end behavior, which is often shown in the graph with a horizontal asymptote. So if I have that this graph as x goes to negative infinity is -1, I know that somewhere on the far left-hand side of the graph, it needs to level off at -1. So now look at B. I'm not going to put really much on the graph quite yet till I have a little bit more information. It says the limit as x goes to -2 does not exist, but the limit as x goes to -2 from the right does exist. So if the limit doesn't exist, we could have a vertical asymptote, or there could be a jump. That's what that information tells me. It does tell me the limit as you come in from the right-hand side exists. So I know if I come in from the right, that is going to exist. And then it does tell me that there is a value on the graph that f of -2 is 0. So there needs to be some solid circle somewhere that f of -2 is 0. And I'm actually going to go ahead and put that on my graph because that has to be definite. And then I'll do C and then kind of put those first three on the graph. Part C tells me that the limit as x comes to -1 from the left is equal to the value. But the limit as x goes to -1 d and e. So this can't be a jump. It would have to be an asymptote. Or I'm lying, there's no left or right. It could be a jump. It could be a jump or a vertical asymptote on the other side of the graph. So putting this all together, I'm going to do it we'll do it in blacking. So I know that somewhere it has to level off at -1, but as I go towards -2, only the limit from the right exists. So only the limit coming in from the right-hand side exists. The limit doesn't exist, so I'm going to draw something that looks like this. So I have it leveling off at -1, but on the left-hand side, it's approaching a vertical asymptote. So I can go ahead and check to see if it works. Yes, this graph is leveling off at -1. The limit overall does not exist. The limit from the right is existing. And the value of f of -2 is equal to 0. Moving on to C, it tells me the limit as x goes to -1 is equal to the value. So I don't know what that value is, but I'm just going to put it there where I happen to end up.
Mr. Brown, I have a quick question.
Yes.
Okay. Why can you put a value there and also have a vertical asymptote there?
Because it's a piecewise function and we can do whatever we want, is the short answer.
Okay.
Like this is not going to be like a traditional family function or anything by any means. So then we have like the limit as x goes to -1 doesn't exist overall. I could do another vertical asymptote. I could do a jump. This time I'll do a jump. We know the left-hand side and the right-hand side can't match up. Looking at D, it tells me that the limit as x goes to 0 exists. So that means coming in from the left-hand side and the right-hand side, it has to match up. But it says that the value f of 0 is not defined. So that tells me like I have this graph that's approaching from the left and the right, but there is no actual value there. So this is actually describing a hole in the graph to me. Doesn't tell me where it's at, so I'm just going to go ahead and draw a line over the y-axis. And we have the limit is existing, but the value is not. Looking at E, it tells me the limit as x goes to 2 exists. F of 2 is defined, but the limit is not equal to the value. So again, if the limit exists, coming in from the left and the right, they would end up matching up. But the actual value is just somewhere else. Whether it's above or below it, it has to exist. It's somewhere else. It doesn't tell me what it is. So I'm just going to go ahead and continue the graph. Coming up to 2, there's another hole, and the value is just located somewhere else. And then looking at F, it tells me coming in to 3 from the left-hand side, we approach the value of 1. Coming into 3 from the right-hand side, we get -2. So from the left, it's going to 1. Coming in from the right, it's -2. And then coming into G, that's going towards infinity, so another end behavior. It tells me the end behavior on the right-hand side is +2. So when I draw this graph, I just want to make sure it's clear that's going up to that asymptote and then leveling off. Now, before I take questions, your graph could look completely different from mine, but I will kind of go through OneNote and check, like, does it look like you're getting the idea of what these limits graphically mean? Like, what does it mean when they're a hole? What does it mean with limits when there's a jump, when there's asymptotes, and things like that? But are there any questions or things I can clarify about my particular graph? Or if you want to just ask a general question about a part A through G.
Yeah, where did the limit from y equals 3 come from?
Which one am I looking at? A, B, C, D, E, or G?
That's my question. I don't know where it came from.
Oh, the value of 3, looking at F.
Uh,
So when I look
oh,
at
there it
F,
is.
yeah,
Yeah.
F, it tells me I'm coming in from the left, I'm reaching the Y value of 1. When I'm coming in from the right, I'm going to the Y value of -2.
Okay. So it
Any
jumps
other questions?
it jumps from 1 to -2. Okay.
And again, I'll look into OneNote if you did it in OneNote. If you didn't, that's fine. If you didn't do it in OneNote and just like want to send me a picture of yours, you're more than welcome to, and I can kind of look over it. Because I do want to make sure you have like this understanding of what limits look like graphically. But that actually brings me to the end of the notes. So there is about 10 minutes left of class, but this is, I know that says Wednesday, but same topic, Wednesday and Thursday.
Isn't the code supposed to be EDEE3F instead of APBC21?
Oh yeah, this is my BC class. I just can't fix anything, apparently. Yeah, because right now my AB and BC classes are pretty much at the same level, but 3DEE, 3F, yes. Thank you, Sarah. So this is the checklist of things that I want to make sure you get done. Please reach out to me if you're getting lost or need help. I do have office hours, remember, every day after school. Things you pretty much have to get done today, like please go ahead and sign up for this section in my AP classroom if you haven't, so I can go ahead and let the administrator in charge of AP stuff know that it's all done for my class. And then also remember your prereq stuff is due Friday at 2 p.m. Since this is also my BC stuff, that due date is not correct. So ignore that. But we can do homework 0, again, is due. You should be able to do all of homework number 1 now. I did look and some of you have already started it. The front page of homework 1 is like kind of like how the warm-up was today, just a lot bigger. There's a graph with a whole bunch of limits questions that I want you to answer. And then the back page is kind of like that last problem we did, where I give you a description and I want you to draw a possible graph. Remember the answer keys to my homeworks are posted under the General tab in Teams. This recording will also be shared later. I'll edit it down and cut off like the very beginning of class and the end a little bit so it's not as long. Will also be posted as well. With that being said, I am done with notes. So if you are good to go, you can go ahead and log out. If you want to hang out and ask any questions during the last 10 minutes, you're also more than welcome to do that as well.
What are we doing tomorrow?
Tomorrow we are going to just barely start doing some more limits, but what we have to do when we don't have the graph in front of us.
Okay. Also,
yeah, go ahead.
Mr. Burton did fake answers on the answer key. Do you do that too?
Nope, if you see a fake answer, it just means I did something wrong.
Okay.
It's also because I I'm checking homework, but like this is a college level class, so for me homework, like you should do it until you understand it. So I'm not gonna purposely post something that's incorrect.
Bye, Mr. Brown.
See ya.
Mr. Brown,
Yes.
I think I'm still getting a little tripped up on this. On like the show what you know, like this, like and these answers could be like